Hello, welcome back to the Looc. In this segment we are going to look at encapsulation and data hiding, how to use the keyword this, how to use static variables and methods, read-only field, C# memory management functions, the class view and object browser windows, and object initializers to create objects and initialize it in the same statement. First we are going to look at an application time1 that represents the time of the day. Here is the code. It's a public class, time1, has private attributes or instance variables, hour, minute and second, has a public method setTime that sets these three instance variables to passed in values, and it performs input validation. So hour has to be between 0 and 24, bigger than or equal to 0 and less than 24. Likewise, minutes has to be between 0 and basically less than 60, 59, and same for seconds. And part of validation check, it throws an exception, an argument out of range exception. We'll look at the details of how to throw an exception. There is a universal time format conversion method that returns the hour, minute and second in universal time format, so 2-digit hour, minute and second as they are stored. And there is a toString method which overrides the object class toString method and displays a thing in a particular format, namely a 12-hour format, so there is AM and PM. We do this by a conditional expression, and if the hour is 0 or 12, then display the appropriate hour and AM and PM. So the class's public methods are the public services or public interface that the class provides to client code. Instance variables are declared in the class body. They can be initialized using the same syntax as a local variable of a method, and we'll see later the output of it. So let's try writing this class first. So time application, and we need to add a new class to our project. So add new item. It's a little slow the first time, and the new item will be a new class, and its name will be time. So instead of class 1, so time dot C#. Actually one already exists. I don't want to replace that. I want to replace this as time test. This is the class that actually has the main method. So let's redo it and add a new item, which in particular will be a class called time, and add, and there it is. That namespace is inherited from some earlier applications, so let's change that in the entire solution. Replace all there. So first of all, it will be a public class allowing it to be used from client code from other applications too, and it will have private instance variables, integer and hour is 1, and maybe we make a comment that this should be 0 to 23 in value, private int minute. This variable, instance variable, should be between 0 and 59 in value, and the same for second. So these will be the three attributes or instance variables that describe a time object. Let's try the set time function method. So set a new time value using universal, that means 24-hour time, as well as throw an exception if the hour, minute or second is invalid. So this will be a public void no return value method set time that takes an integer h for hour, an integer m for minute, and an integer s for second. Here comes the body of the method, and the method set time, and in the body of the method validate hour, minute and second. So the validation is an if statement. If there will be several statements concatenated with logical functions, the first one being h is greater than equal 0 and the double ampersand h less than 24. So that's one condition we want to enforce. And simultaneously our second condition will regard the minute. So m is greater than 0 and less than 60, being integer that allows only 59, and the third condition likewise for second is greater than equal 0 and less than 60. So if all these conditions are met, then the body of the if follows. Let me correct some typing that, and that's the and if. So in this case we just have to set the instance variables. So hour equals h, minute equals m, and second equals s. So the passed variables are correct values, so we can set the object's instance variables. Otherwise we have an else statement, and in this case we throw with the throw keyword, and we have to create an exception, and one of the exceptions that are available is argument out of range exception, drops down by IntelliSense, and we are going to discuss the details of that. For now we continue writing the class. The next method is to convert to string in universal time format, which is, just to remind ourselves, double digit hour, double digit minute and double digit second. So another public method, it returns a string and the name will be to universal string, takes no argument, and that's how the method will operate. And here is the end of it. To universal string. Nobody yet, so we have to deal with that, and I'm checking for a second if I set everything up right here. Why am I getting this underline here as if I am missing something, and that's the return value is not done yet. Okay, so what we want to is return and a string that has a format method, and in this we specify a particular format, namely our first argument, in reality 0th, colon our first argument, 2-digit integer, and too many colons there. The first one as a 2-digit integer, and then colon the second one as a 2-digit integer, colon, and no colon, and our third argument, and that's our format string. And what we still need to pass on is the three instance variables that we are going to display, and semicolon there to end the statement. So this will be in universal format. So hour, minute, second, and that's the end of that method. And we have to write one convert to string in standard time format, which is our minute, second, AM or PM. So this will be public override. No, wait. Override string return type toString. That's the correct name, and the default implementation is not what we want. End method toString, and this default implementation is not what we want. actually what we want here is the thing that I wrote there previously, so let me copy that. And that's actually correct here with some modification. Meanwhile, the first one should have been just general, so 2-digit integer, and there is no third argument here really, because it's just hour, minute, and second. Here, however, so the two universal string, the standard time string, however, the format string is correct, but we have to put in a ternary expression, also known as a conditional expression, so we check whether the hour equals 0 or that hour equals 12. Don't need that parenthesis there, and then depending on the result, so question mark, if it's correct, so the hour is 0 or 12. If the hour is 0, then we are going to output 12 colon our remainder operator that is modulo 12, and that's our ternary expression. In other words, comma, so that sets the hour. So the hour is 0 or 12, then it's if we display it as 12, and otherwise, if it's not a multiple of 12, we display the modulo of it divided by 12, the remainder of it divided by 12, so that's what the hour will do, and therefore it will be our first argument, and it will be always between 0 and 12, and then as before we have to display in the minute and the second, and finally there is one more argument, AM or PM, which will also be a ternary expression. So in particular we are going to display that if hour is less than 12, if that's true, then display AM colon, otherwise display PM. So that's the end of the ternary expression, and we have to close the actual format method. So let's look at it one more time. Our first argument itself is a ternary expression that displaces 12 if the hour is 0 or 12, otherwise the remainder of it, so it will be always less than 12 or at most 12, and then the minute and second, and we need an AM expression as well. So that will be the end of the method of toString. Let's save all this, and to see if there is no syntax error, we need to compile it. I see a little bit of a problem at the constructor for the argument for the throw argument out of range expression, and therefore I have to check a little bit what goes before that, so that every parenthesis is correctly lined up. So those seem to be correctly lined up, and so are these. Oops. So that particular one. So all the others seem to be lined up. So why is this expecting here one more? Because we are missing the end of the actual method. So end method set time was missing there. So that should be there. We have to complete the body of the method. So that's our class. Let check if everything is fine. I see one more thing. This will be this closing will be the end class time, and that would be the end of the namespace. So that parenthesis is supposed to line up. You can select that, and that's supposed to line up with the very first one. And class time, that's incorrectly lines up. And method set time, this was there but in the wrong place. Okay, so having written that, so the end method set time, this line ended up a little bit out of place, causing problems. So now that we don't have any more underlines, it's time to rebuild the solution. And if there is no error, we are ready to write the test harness for this program. In other words, okay, that's will be our other class. So let's try this rebuild again. Okay, succeeded. So this is our time class within the time namespace. Now there's another file that contains the time test class. The namespace is the same, but the class name should be, of course, different. That contains the main method. So let's try to create and initialize a time object. So it will be time and available type now, lowercase time for the name, and it will be a new time constructor. So, oops, it's supposed to be a semicolon there. So comment here that this invokes time constructor. So that created a new time object, and let's try what happens in various scenarios when we output it and the various output methods. So output string representation of the time object. So it will be a console write method, and the first attempt to output this will be a title the initial, say, universal time is colon space, and and that's it. That's actually the header we want, semicolon at the end. And having done a header, and it doesn't matter, but maybe we don't want to. Having done a header, we are going to display time dot to universal string. That's one of our methods, doesn't take any argument. So that's one way to write it. Let's try the other way, another write method, and this time the initial standard time is end of that header, and another console write line. This should be a write line, actually want a new line after it, time dot toString. It's an override of the object class's toString, and one more, no, write line for just to have a new line drop. And actually when I am printing out the universal string, that's a write line as well. So this set of inputs, this set of outputs will display the time as it was created with a constructor with no data passed in at all. So we didn't specify any time for these values, but they are integer types, and therefore they are initialized to their 0. So let's try to build the solution at this point. And run it, Control F5 to test it out. And there it is, that the initial universal time is 0, 0. It should be 0, 0, and the initial standard time should be 12:00:00 a.m. So something went wrong in our output, so we have to check on that. But the initialization happens. So little typo there, that's D2, and since I copied little typo there, that's D2 as well. Little attention span check. So let's run it again. This will rebuild it, and there is the initial standard time and the initial universal time. All of them are uninitialized and therefore set to 0. Maybe I can put a space in front of standard just for better looks, and we see the result as the initial universal time is 00:00:00, and the initial standard time is 12:00:00 a.m. as it should be. All variables are actually initialized to 0, but the standard time we formatted in a way that when it's all 0, then it comes out as 12 a.m. in the output. So that's the initial form of the object with a created by a constructor here that takes no argument, and therefore all instance variables are their zero values if numerical, and object and string set to null, and booleans to false. So let's change time and output updated time. So this time we are going to use the same time object, but we use the set time method that we had and set it to 13 hours, which is 1 p.m., 27 minutes and 6 seconds. So that changes the time object, and we can output the same output, except we are going to change the initial, the word initial in there. So universal time after set time, maybe write it that way, universal time after set time is, and we can say standard time after set time is, and we display. Maybe we can also comment that here we were just dropping a blank line, so output blank line, and that same comment can be applied to that. So let's save our program in this form and rerun it. That rebuilds it as well as runs it. So here is our output. The initial, universal and standard times are as before, and universal and standard time after set time, 13 hours 27 minutes 6 seconds as 2-digit displays, or 1 p.m. 1:27:06 p.m. So here is our output. Maybe I move it in the corner here, and that's the output using the time object as it was originally constructed, with no instance variable set to any particular value, and therefore came out as 0:00:0:00 or 12 a.m. and then set time with set specific values and got it formatted in both cases, either universal or set time. And the methods to do so are shown in the class itself. So to universal string, that is the first output with the 0 zeros, or the 13:27:06, and the second one, which is the trickier second output, in which case we need a ternary expression or conditional expression for the hour, so that we always end up with the right hour, basically the hour remainder of 12, unless it's 0 or 12, in which case it should be 12, and we need another ternary conditional expression to set the PM correctly. So that's the second one here that allows us to put the PM correctly. So that's our second set of outputs, and to test the class even further, let's now attempt to set time with invalid values. So when we do this, we can do it in a try and catch block. So we can say try, and that's the end of the try block, and try, followed by the catch, where we can specify what we are attempting to catch, and that's what we are attempting to catch is not fish, it's an exception. In our case, it's an argument out of range exception. Let's call it sum. It's an object of that class, so EX for exception, and here is the catch block. So this will be the end of the catch block. So there are two blocks here, a try block and a catch block, and in the try we do what we like to do, but we are not exactly certain that it is correct. So in such situations we often do things in try and catch blocks to make sure that if there's an exception we can catch it and we can handle it in some other way, generally, than necessarily just simply crashing the program. So here we use the time variable, set time, and let's put in something really crazy, 99, 99, 99. That's obviously not a correct time to set. And then for simplicity, unless we want to do something more elaborate, we can just display the result. An exception has a message variable that is built in by C#, and then we can drop a new line after that, and that will give us some information about what the problem is. So let's try and run the program in this form. So Control F5 to rebuild and run it, and here is our previous two outputs, and then the specified argument was out of range of valid values. That's the standard message that an argument out of range exception throws. We can do something more sophisticated or more relevant and appropriate depending on the situation in the catch blocks. In this place we just displayed the standard error message that comes from the type of expression we are throwing. And display time after attempt to set invalid values, just to try out whether what happens if we try to print the object again after we tried the invalid time setting. So this entire block of outputs will apply. So I'm just copying them in, and time to run again, see what happens. You can think about what you predict would happen. So here it is, and let's see if your prediction was correct. And as a matter of fact, we can see that what happens is that when we try to set invalid values, and we threw an an exception. Specified argument was out of the range of valid values, and we print the object again. Well, it didn't change, so it outputs its old values, and the reason for that, of course, is because in the time class, when in the setTime method we set the hour, minute, and second instance variables only if they are in range values. Otherwise, we threw an argument out of range exception, and then in the else part we don't set the hour, minute, and the second, and therefore they remain unchanged, and that's why we see the time displayed as to run it again as unchanged. So the previous values are still there. So that's our program, and the next segment we look at another form of setting the time using the this reference.